Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous lecture, we have just started the new chapter of polymerization reaction, in which we have defined what do we really mean by the polymerization process. And we have seen three types of the process as addition polymerization, condensation polymerization and copolymerization. If you have missed that video, you can find it in the I button over here. Now, having said that, in this video, we are going to mainly focus on addition polymerization. Well, we have already seen addition polymerization can be termed as direct addition of a single or more than two monomer in a repetitive basis. So we can say that addition polymerization is just simply addition of monomer in a repetitive fashion. Well, we have seen that this addition polymerization can only be done with the double bond or triple bond. Well, this addition polymerization can also be done with the functional group as well, but that is the exceptional case. In majority of the case, addition polymerization can be done with the compound which have double bond or triple bond. So we can say that the polymerization reaction in which the polymer formed by direct addition of a repetitive monomer unit is called as addition polymerization. And it requires presence of at least double bond. Well, we can do this with functional group as well, but that is exceptional case. And we have also seen that in addition polymerization process, no byproduct is formed. So in addition polymerization process, double bond breaks apart and this bond is being shared with two carbon atoms. Now these two carbon atoms are ready to make a chain and in order to produce the polymer. So sometimes this addition polymerization process is also referred as the chain polymerization process. Now as you can see on the screen that a compound which has carbon, double bond carbon, so if we supply some amount of energy, this bond will break apart and this bond will be shared with by these two carbon in an equal amount, so that this both the carbon or particularly this monomer can join with another monomer in order to form polymer. So this is what do we mean by addition polymerization process, in which different monomer are continue to join each other. The example for this addition polymerization can be considered as vinyl compounds and olefins. Now basically this addition polymerization process can be seen in this image as well. You can see that we have used, let me just rub all this thing so that you can see it in a clear way. As now you can see that this ethene molecule in which two bond or double bond is broken up and converted into single bond and both the bond are shared by the carbon. Now these two carbon can be linked with each other to produce a long chain of polymer, and this is why we call this thing as the chain polymerization process. Now this addition polymerization process involves three different types. The first one is known as the free radical polymerization. Then we have ionic polymerization and lastly we have coordination polymerization. Here in this animation you can see that the free radical polymerization, in which the free radical are continuous to form and they are continuously connecting or linked with another monomer in order to form long chain of polymer, as you can see in this animation. So this free radical polymerization involves generation of free radical, which we denote with the dot sign on the polymer compound named as R. Well, this R is specially referred for the carbon hydrogen chain or carbohydrates. So whenever we use R, it represents some amount of carbohydrate. Then we have ionic polymerization, in which ions, either cations or anions, are being produced and they are responsible for the linkage of another monomer in order to form long chain of polymer. So in ionic polymerization, we will generate ions, either cations or anions. And in free radical polymerization, we will generate free radical. Basically, these free radical are nothing but compound which has a free electron to their outer periphery. Then lastly, we have coordination polymerization, in which we will use a special type of the catalyst which involve organic metals. So addition polymerization can again be classified into the three categories. First one is the free radical, in which we generate free radical so that we can initiate the polymerization process. Then the second one is ionic polymerization, in which we generate ions, either the cations or the anions, so that we can continue the polymerization process. And in a coordination polymerization, we use a special type of catalyst that involve organic metals. Now, let's understand what do we really mean by free radical polymerization process in detail. So now, as you can see on the screen, that this free radical polymerization involves further three steps, or any polymerization involves three steps. The first one is known as the initiation. Then comes the propagation, and lastly we have termination. So initiation of polymer chain growth is brought about by the free radical produced by decomposition of compound called as initiator. So in a free radical polymerization, we use a compound named as the initiator. This initiator decomposes and produces free radical, and this free radical are mainly responsible for the entire polymerization process. In ionic polymerization, we use compound which generate ions. So now let's just focus on the free radical polymerization first. But here one thing comes in mind, that what do we really mean by this initiator? What are these compounds that we call as initiator? So let me just quickly explain you what do we mean by initiator. So initiators are thermally unstable compound and decompose into product what we call as the free radicals. So initiator are special type of the compound which are thermally unstable. That means they have free electron, readily free electron on their outer periphery. So if we supply some amount of energy, their electron can be easily liberated off, and we can use this electron to pair up with some another monomer. So such compound are called as initiator. So such compound are called as the initiators. Here in this animation you can see that this green are the initiator. They are combining with another monomer or another molecule so that they can form a long chain of the polymer. Then process comes as the propagation, in which this polymerization process further continue, that we will understand in upcoming section. So when energy is supplied to this initiator, they split into the symmetric compound and each carrying the electron from each electron pairs. When molecules split into two identical fragments, it called as the homolytic decomposition. So now let me just further explain you what do we really mean by these initiators. Let's suppose this R dash R is our initiator, like this. Here on the screen you can see that this R dash R is our initiator. Then we can represent this initiator in this way as well. R two dots R. So here these two dots represent their electrons. Now if we supply some amount of heat or any form of energy to this initiator will decompose into free radical like this. This particular free radical will have its own electron so that it can pair with another monomer. And this particular initiator will also have its own free radical which can also be linked with another monomer. So now in this way we have formed two different free radicals that can be used for the polymerization process. So this is what do we really mean by the initiators. Initiators are the thermally unstable compound which can form the product called as the free radicals, and these free radicals are responsible for the polymerization process. Now let's understand this initiator with one example. So let me rub this thing, and we have one example of benzoyl peroxide. So this benzoyl peroxide compound can be represented as this, is basically contains two benzene ring in this fashion. like this is the one benzene ring. Then it also has one more benzene ring in this way, and both the benzene ring are connected with C-O-O bond in this way. So basically we can say that it has C-O-O as a functional group in this manner. So now when this particular component will undergo the heating process, or if we supply some amount of heat to it, it will decompose into the initiator or substance what we call as the free radical in this way. Now two components of same molecule can be generated which has C-O-O like this. And if we further supply heat to this compound, then this compound will decompose in this way and it will produce 2 mole of benzene as this and 2 mole of CO2 gas like this. So we can say that this compound was like this, and if we supply some amount of heat, it produces free radical in this way. You can see here this particular C double bond O will have its own free radical. So we have produced two free radical in this way. And further if we supply heat, then this component will decompose into the benzene ring and it will produce 2 mole of CO2. So this is what do we mean by initiators. Now let's understand the first step in the addition polymerization process, and this first step is known as the initiation process. The initiation is basically the first step in the process of polymerization. During initiation, an active center is being created with responsible for the polymerization process. Now, after this initiation step, propagation step come next. We will see this propagation in the next video. Till then, keep watching, keep learning. Thank you.